Today we'll do Pythagoras theorem. We'll do two exercises. The first bit is we need to know the side opposite to the right angle is called the hypotenuse. It is also the longest side of the right angle triangle. Pythagoras theorem applies to any right angle triangle. Lengths can be expressed with exact values using surds. Surds are numbers like √3, √5, etc. Okay, but √4 is not a surd. This is just 2, not surd. Okay, sorry. So the Pythagoras theorem says that C, A, and B. So to get the Pythagoras theorem, we write A squared plus B squared equal to C squared. If you know it, that's good. Right? It doesn't hurt to write it again. Let's find the length of the hypotenuse. We'll look at the first example. How do I do the first one? Started with C squared equals 5 squared plus 12 squared. Use your calculator. So have your calculator ready. If you need to borrow one, come to the front. I've got plenty in the drawer. Yep.
You know, underneath length where you've written something and then on top of not surd, what does that say?
2. Square root of 4 is 2, not surd. Yeah. Yeah. What do you get? What do you get? 169. Once you get 169, you have to square root to get the answer, which is exactly 13. You don't need to correct to 2 decimal place. Yeah. Why is it not 17? Because you have to add the square, not 5 plus 12. It's 5 squared plus 12 squared. And then you square root it. Okay. Any question? Let's try the next one. The next one is you go C squared equal 9.5 squared plus 7 squared. Use your calculator. Let's continue. Alright, let's do 9.5 squared plus 7 squared equal 139.25. And then you square root to get the answer, which you will get 11.8. 11.8. So 2 decimal place, 11.80. Get the idea? But the question says so. Alright, sometimes they don't want it to be 2 decimal place. They want it to be exact value, which is the surd form. So in this case, if you do C squared equal to 2 squared plus 5 squared, on your calculator you get 29. But you can't square root 29 because you get decimal, isn't it? So when that happens, and when the questions say exact form, you have to write root 29. That's it. That's your final answer. That's called the exact form, because it's exactly root 29. But if you round it, it's not exact. That's approximate. Right? It's not exactly 5.39. It's a very long number. We're not going to write everything, so we'll just keep it as square root of 29. All right, any questions? So now you know how to answer the question, how to find the answer, how to find 2 decimal place, how to do it in exact value. Yes? Okay, we've got one more page to go through, then you can start the exercise today. All right, all ready? Yes, just do the hard question. Skip some easy ones. All right, let's do the first one. For each of the following, find the value of the polynomial. Round your answer in part B to 2 decimal places. Give an exact answer to part C. Let's start with this. Now, if you're finding the shorter side, what you do is instead of add, you subtract. See, I subtract the hypotenuse by this. So instead of plus, you minus when you find the shorter side. So you do it on your calculator. You do 17 squared minus 15 squared equal 64. And then you square root 64 to get the answer 8. Get the idea? Pretty easy. Good. Yeah. Oh, no, you can't. You have to put that C. That's the hypotenuse. You can't switch. Okay, what if you do x? Find the next one, you do x squared is the hypotenuse square minus 7.6 square equal. And there you go, 10 square minus 7.6 square, 42.24. And there you go like this, 66.499. Now, how do you round that to 2 decimal places? Let's try to do that. 6.4992. All right, so if you round to 2 decimal places, what would it be? 6.50, yeah, because you have to add 1 to the 49, that becomes 50. Okay, now there's some harder questions towards the end. Let's go through them. All right, all finished. Okay, now if we look at the third one, that's a bit challenging. What type of triangle is this when we have these markings? Isosceles. So we have 2 sides missing. So that will be a bit hard using Pythagoras. So we have to use some algebra. So in that case, what you need to do is to write x squared plus x squared equal to 3 squared. Now what happened to the x squared plus x squared? What would it become? No. X squared multiplied by x squared is x4. But that's times it. We're not at times, we're adding. So what would that be? 2x squared. They're like terms. 3 squared is 9. So be careful. So be careful about the rule. Y plus y is 2y, but y times y is y squared. So people get mixed up with these two. So be careful with it. Okay, let's continue. So how do I find x squared? What's the first step? What should I get rid of first? The 2. So how do I get rid of the 2? Divide by 2. Very nice. What's 9 divided by 2? Yep. Now, actually, I want to leave it as 9 over 2 because I want to square root it. So the questions say leave it in exact form. So we write x equal to square root of 9 over 2. Okay. That you do go further because if you go square root of 9 over square root of 2, what's square root of 9? Yeah, so you split the square root in 2 parts. So that's your final answer. So you split the square root into square root of the top over square root of the bottom. Square root of 9 is 3. Square root of 2 is just square root of 2. It can't be square rooted. So that's your exact form. Well, you just go further, so it looks a bit. So I get to square root the 9. Yeah, you need to be exact form. Exact. Alright, I think the last one's super easy, so I'll just give you the answer. X is 5, okay? Alright, check later. Okay, so please do the work for 3A and 3B today. Any question, let me know. Now, look carefully, study C carefully. That's the only example that's new to you, or possibly new if you have done it last year. Well done. Okay, good. So